Hello and welcome to today's European SharePoint Office 365 and Azure Community webinar. My name is Shane and I'm delighted to be joined by Aidan Finn, MVP InnoFactor Ireland, who will be talking to you today about how to digitally transform and keep your on-premise file servers. Remember to join in the conversation about today's webinar on Twitter. Our Twitter handle is @EuropeanSP and our hashtag is ESPC20. Don't forget to check out the Resource Center. This is updated daily with the latest blogs, ebooks, webinars, and how-to videos. Simply visit sharepointeurope.com and click the content link at the top. We've just announced ESPC 20 online from the 14th to the 15th of October 2020. See sharepointeurope.com for full details and more exciting news such as keynotes by Jeff Teeper, Caruana Gatimu, and Scott Guthrie. After the webinar, we will have a questions and answers session. Type any questions you have in the questions window. Questions will be selected and answered at the end of the presentation. This webinar will be recorded where you'll be notified by email when it is available. And now I'm going to pass you over to our webinar presenter, Aidan Finn. Hello, Aidan.
Hey, good morning. How are you?
I'm great. Aidan, take it away.
Cool, thanks. Good morning, everyone, and greetings from North Kildare in the Midlands of Ireland. And as you just heard, I'm going to talk to you about how to digitally transform and keep your on-premises file servers. So we're in a world where you're constantly hearing move to the cloud, move to the cloud, move to the cloud. And the reality is for some organizations, for many organizations, no matter what size they are, doing a complete abandonment of on-premises just isn't feasible. We actually live in a hybrid world, and this is something that you may not notice if you go to a big conference like Microsoft Ignite or whatever, back in the days when we used to go to conferences. But this is the reality, and this is something that Microsoft actually understands. The hybrid life is the way that businesses will continue to operate for the most part. Okay, so I'm Aidan Finn, and I'm an Azure MVP. I just got awarded for my 13th year as a Microsoft Valuable Professional. This time, actually for the last few years, I've been an Azure MVP, and previous to that, I've been Hyper-V and System Center Configuration Manager. I'm principal consultant with InnoFactor Norway, so I live the cloud lifestyle. I live in the Midlands of Ireland. I work from here, and all my customers are actually up in Norway. And I deal with them online only. I have actually spent a total of 1 day face-to-face with customers in Norway and 2 days in meetings with my colleagues in Norway. The rest of it's completely Teams and Edge with the Azure portal and through DevOps. I own my own company called Cloud Mechanics, which you can learn more about on cloudmechanics.com, where I develop my own Azure training and teach it. I used to deliver that around Europe, but of course these days we can't do that sort of thing anymore. So I've switched to doing it online. So my next class is actually on July 30th. It's called Securing Azure Services and Data Through Azure Networking, where I basically share a lot of what I have learned in the last few years in implementing and deploying and maintaining a secure infrastructure for platform and for IaaS in Microsoft Azure for mid to large customers. So there's a lot of stuff in there you won't find documented by Microsoft, and certainly won't find in the Microsoft training course. So file servers, the good and the bad. I'm going to assume that you've moved everything to SharePoint, right? That's what Microsoft told you to do, put everything in SharePoint. Now, you may not know it, but when you're putting stuff in OneDrive for Business or you're putting stuff in the Teams, it's actually going into SharePoint. And of course, you've done that, yeah, and you've no more file servers. I'm kidding. The reality is most people don't find SharePoint usable. And it's weird saying that in an event or a webinar that's run by the European SharePoint conference. But most people have resisted that move to SharePoint. Most businesses have resisted that move to SharePoint, even though it's one of Microsoft's biggest earners, because users find it alien, and there's a lot of retraining that has to be done. The reality is a lot of content is staying on the file server. That could be for many reasons. It could be for usability. It could be because of integration with other services. It could be for latency reasons. You're doing, editing CAT files and constantly downloading those from SharePoint. Just silly. It's just not going to work. So file servers are still around. They're not gone anywhere. I'll be quite blunt. Microsoft, it took them a while to realize this. When we went to them as MVPs and said, hey guys, this whole SharePoint thing, it's not going to work. It's not for everyone. There are times where using SharePoint, whether it's directly or indirectly through Teams or OneDrive for Business, they're great, but there's other times where that file server needs to be around. And it took Microsoft a while to get around to that concept. And what we're going to talk about today is kind of that realization of that and the implementation of a better picture or a better scenario, a better solution where the file server is still a part of your world, but it integrates into the cloud to give you a better solution. So that file server is still there. Small businesses, large businesses, they are there. I deal with them all the time. I hear about them all the time. They're in branch offices, they're in headquarters. Why? Because they're better performance, they're familiar. You have an investment in the hardware, you're not going to dump it. There are dependencies and line of business applications and services. And as I said, some of the cloud offerings just aren't going to be right for everybody. And they're going to be good for a lot of people, but not for everybody. But with that file server, we have problems. We have issues with synchronization. We've tried synchronizing files using DFS replication, and you know what? It's not been great. We've ended up having to learn an awful lot about how DFS replication works in order to fix it. We're constantly dealing with capacity issues. It's rare that I work with a customer and we start talking about file servers or whatever it is, or storage, and they have enough storage. Very rare. And no matter how many disks you put into that file server, or how much virtual disk capacity you add onto that file server, there's never enough. It's just a constant battle, and that's never going to stop. Files are getting bigger, and the need to retain data is increasing as we get more and more regulatory compliance issues. Then we have backup issues. And slowly, we're moving services away from on-prem, and suddenly we're just going to have, domain controller, file server, and a backup server. And why the heck do we have that backup server? And then if you're dealing with branch offices or retail locations where there's local file servers or whatever it is, you have to not only just put the file server there, but you also have to implement a backup solution. And how are we going to deal with that? Are you gonna have distributed backup solutions in all those environments? Does that mean you're gonna have tape libraries? Oh my God, all this stuff that's just sitting out in that branch office. And of course, then you have disaster recovery. Does that mean I have to replicate that file server to somewhere else and to be able to restore it? And what happens if I get hit by one of these encryption malware solution or things out there, and it wipes out my network? How do I recover from all that? It's going to take me ages. Am I going to have to invoke my business continuity plan? Am I going to have to restore from all my backups? Are my backups encrypted as well? So there's a lot of questions, a lot of problems we have to deal with. So what if we could take that file server and leave it there, whether it's physical or virtual or whatever it is, so the old usage patterns continue, the integrations with the legacy line of business solutions are still there. But what if we could synchronize what's valuable on that file server? The file server itself is not that much value. It's an asset that depreciates to the business. But what's really valuable is the data on that file server. What if we could take that data, we could replicate it to the cloud? And that cloud replica is now the master copy, not what's on the file server. We're going to re-envision that file server now as a cache. So it's a different device. And because it's a cache, it only needs to retain what's being used or what's been used recently. But everything is now in the cloud. Now, if everything's in the cloud, we can move the backup to the cloud as well. So we don't have to put infrastructure on-prem to back up that file server. So if you're dealing with branch offices or retail outlets or whatever it is where it's multiple file servers, we can get rid of the backups for those. Those file servers are now less important because they're just a cache. The content is all in the cloud. All the content is in the cloud. and the backups are in the cloud. And if the system is clever, if we lose one of those servers, let's say it blows up, there's a fire, or everything gets encrypted by malware. Well, but because we've got a master copy that's secure up in the cloud, that's isolated away from the on-prem environment, we have the ability, if it's a clever replication system, to recover that in a matter of minutes. All we need is a new machine, put an agent onto it, and recover everything in minutes. No matter how much data there is, to recover it in minutes and get users back operational in minutes. Sounds too good to be true, but it's actually called Azure File Sync. Cool service was introduced a couple of years ago in Azure. Still not that many people know about it. And it was one I knew was in development for quite a while before it was first talked about publicly. And I knew it was going to be a killer feature, and in my mind, it absolutely is. If I was an on-prem sysadmin and I was responsible for file servers, first thing I would actually do is deploy this service out to those file servers, and that is the absolute truth. This will, through an agent that you put onto your file server, will synchronize your selected folders or shares to the cloud, into Azure Files. And that's using a general purpose storage account. In particular, I would recommend the general purpose V2 storage account because of some new stuff that just came out this week. It is built on a synchronization engine called a Microsoft Sync framework. Now, most people will not have heard of that. However, if you're deep into SQL Server, you may have heard of that because that particular technology is quite mature. It's been used for the availability group feature of SQL Server. And if you want to talk about mission critical, it's availability groups in SQL Server. That stuff has to be rock solid. So that is a mature, reliable sync engine for synchronizing your files from your file server to the cloud, and hence to other file servers as well if you wish. With tiering, we can replace files, cold files, and we'll talk a bit more about this later, with reparse points. You can think of those as pointers. Basically what that'll do is, instead of you having these 10-year-old files taking up capacity on your file server that you have to keep around for whatever reason, they're replaced with basically 0 bytes pointers in the file system table. So it's not stub files. There's actually nothing taking up capacity. It is just an index entry on the file table that points to the replica in the cloud. And the permissions stay the same. Nothing actually is changed at all, other than you're reducing the amount of used capacity on the disks. And that means your file server doesn't need to be as big. It doesn't have the same pressure to constantly have a massive amount of disk space and constantly be growing, etc. Because now everything is up at the cloud, we move the backup function. So we're actually going to use Azure Backup. Now you're getting off automatic offsite backups. That's one of the things you're supposed to do with your 3-2-1 strategy in backup, is make sure you have an offsite copy of your backup. Now you do, automatically, because your backup is actually happening offsite. And in case you're wondering about how many copies there are of your backups, by default there would be 6. 3 in your selected Azure region where your general purpose V2 storage account is, and 3 asynchronous replicas in the paired region, which is documented on docs.microsoft.com. So for example, if I was deploying my storage account into Azure West Europe, which is in the Netherlands, I would know there'd be 3 copies of my backup there, and I would know by default there would be 3 copies of which is in the paired region, which is in North Europe, which is about 40 kilometers from me here in West Dublin. And then we get disaster recovery automatically. There is actually nothing to enable disaster recovery. As soon as you synchronize your files to the cloud, you have a disaster recovery solution for that file server. So if I lost that file server, I can drop in a new file server, connect the sync agent onto it, register the file server with the sync service in the cloud, and within minutes, all the reparse points for all the files will appear on that new file server, which means users can start downloading files. As soon as they open a file in the files, or when they open the share, the files will appear the same way as they did before. The icon will be gray. They double click that Word file. It'll be downloaded automatically by the sync agent on the file server, and it will open up for the user on their PC. As far as the user is concerned, it just took a few seconds longer for the file to open. They didn't see anything happen in the background other than it seemed to take a little longer to open the file. And it's automatically now on the file server because it's now considered a hot file. And that literally, to get that back operational, is minutes. I've seen it actually work in about 30 seconds, to be quite honest. This sounds like something Microsoft used to sell called Store Simple, and some of you out there may have had the pleasure of owning a Store Simple appliance. Big physical thing, also existed for a while as a virtual appliance, and some of you may even still have that virtual appliance. This was a solution Microsoft bought several years ago, probably about 7 years ago, maybe even longer, and then sold to customers as a block storage system, kind of like a SAN. And it supported iSCSI and SMP3 shares. And it was a block-based system. It's not a file-based system like Azure Files is. So it was generic. So we could put anything in theory on there, but you had to realize that whatever you were putting on there could be tiered to the cloud. And it offered multiple tiers of storage. It had SSD storage. It had serial SSD, non-serial SSD. It had spinning HD, and then it had cloud storage as well, which in theory could also be used with AWS and other cloud services as well. Basically, it's a deprecated service at this point. If you want to migrate from Store Simple to Azure File Sync, contact the Azure Files team at azurefiles@microsoft.com. They'll help you move from Store Simple to Azure Files. So let's start diving into how Azure Files actually works. So we're going to go layer by layer. We're going to peel the onion just to start with the concepts, and then we'll go a little more into the components that you'll see in Azure. So we start off with multi-site sync. We can have a file server running in one location, synchronizing to the cloud. And because that cloud replica is now the master copy, we can connect up other servers to that same master copy and sync them. So we can have headquarters syncing to the cloud, and we can have all our branches syncing to the cloud as well. That basically means anything that happens on any one of those physical file servers or virtual file servers, if you're running VMware, Hyper-V, or XenServer, or whatever, will synchronize around the network. That will happen almost instantly. The experience for the end users will not change. They're still accessing shares. So if you have users or applications accessing those files, they're still going to access them over the shares on that file server. From a concept point of view, as an administrator or an operator, those file servers are now less valuable. They are just a cache. That's all they are. They're replaceable appliances now. The master copy, as I said, is in the cloud. That's the main thing to understand about Azure File Sync, is that master copy is in the cloud. That leads us to cloud tiering. We have file servers struggling with capacity. We're constantly adding in disks, never enough. Users are just dropping everything you can think of into there. If you enable cloud tiering, which can be done on a server by server basis, so you can have different policies for different servers, and different types of policies as well. Azure File Sync will monitor the usage of your files and the age of your files, depending on how you've done your cloud tiering policy. And it's a temperature-based system. So if files are considered to be hot, they will be retained. If files are considered to be cold, they will be replaced on the file server with a reparse point, which is basically a pointer in the file system, as I said earlier. That will redirect the file system to the file up in the master copy in the Azure file share. But the end user, as far as they're concerned, nothing has changed. The permissions are the same, the file type is the same, the file location is the same, the icon is just a little different, it's gray instead of the usual colored option. And that basically means that when cold files are converted into reparse points on the file server, we start reducing the amount of disk capacity used on the file server. Now, because we've got our backup or our master copy in the cloud, we replace that backup solution on-prem and we move it up into the cloud. So now, let's say I have 20 branch offices. I don't have to maintain 20 backups for my branch offices. I now have one backup that I maintain up in the cloud using Azure Backup. If I lose a server, well, everything's in the cloud. As I said, drop a new server in place, register the file sync agent on the file server, And now all the reparse points for my shares will appear on that file server within minutes. That basically means my users can start consuming those files once again within minutes. There's no restore 10 terabytes of data from the cloud. It is literally metadata being downloaded, and then files are downloaded on demand, which is a cool solution. And then tiering kicks in once again, assuming you've enabled the tiering policy. Now, if we look at the components, the Azure resources that are involved in this, we start off with our file server. So we have a file server, and it's got a number of folders that I want to sync, which could be shared, don't have to be shared. And we refer to those individual folders that we want to synchronize as server endpoints. We get ourselves an Azure subscription, and we'll put a general purpose V2 storage account in there. And that has the Azure Files API. And this is the service within the storage account that we're going to be using for our synchronization. We'll create a storage sync service, which is going to be associated with that general purpose V2 storage account. Then we will download an agent onto the file server, and we'll register it with the sync service. Basically do an authentication and associate the agent with that storage sync service. Now that agent is talking to the storage sync service, and it's able to download instructions from the storage sync service. No need to open up any firewall rules from Azure into your on-prem network. It's an outbound connection from the file sync agent to Azure. And then for each of the server endpoints, the shares or folders on my server that I want to replicate, I will create a share in Azure Files. So let's just focus on that accounting folder on the D drive. We'll create a share in Azure Files called accounting. And then we're going to create something called a sync group in the storage sync service. A sync group is a mapping of that on-prem folder to the cloud endpoint or share that's now in our Azure Files. So that share that's in Azure Files is now referred to as a cloud endpoint. With that sync group, we now are synchronizing from on-prem to that share in Azure Files. And we can associate multiple registered file servers with that same sync group, which is how we synchronize folders from one server to another through that storage account in the cloud. Then we can scale that out. So we can have multiple sync groups. However, if you've been designing your file server cleverly, when you put all your content into a single folder, you may only need one sync group. It really comes down to how your file server is laid out, how much capacity you're dealing with, and what scale unit of storage account or Azure file share you created. So you have the option of creating 5 terabyte file shares and 100 terabyte file shares within your storage account. And of course, then everything's up the cloud, and we back it up using Azure Backup, and we can configure and associate tiering policies with our sync groups. So we can have different tiering policies for each of our sync groups. The deployment process is pretty simple. Your requirements are you have a supported version of Windows Server. So that's Windows Server 2012 or 2 and later. Full or core, doesn't matter. So 2012 or 2 or later. You need to have at least 2 gigs of RAM on the file server. And if you are using Hyper-V, make sure that dynamic memory, if you're using that feature on the file server VM, is set to start with a 2 gig startup RAM and a minimum setting. This is leads you to an interesting scenario that I found during the preview days. That storage sync filter driver that is responsible for tracking the temperature of files. If it doesn't see 2 gigs of RAM when it starts up, it will fail to start. It will not check again later. So you need to make sure that the file server starts up with at least 2 gigs of RAM and always has at least 2 gigs of RAM. It's not that the storage sync filter server or filter driver is going to use 2 gigs of RAM. It just expects to see it. And if it doesn't see it there, it's not going to start for you. So watch out for that one, especially if you're using virtual machines. You are using the latest version of the PowerShell modules for Azure. That's important because the agent is going to use those PowerShell modules. It does support different configurations, so it'll support standalone file servers. It'll support your traditional active-passive file server cluster. It supports DFS namespace. And then we get to the subject of antivirus. I would expect that you do have some sort of antivirus solution on your file server. The sync agent will respect an attribute on the files called file attribute recall on data access. Your antivirus needs to respect that particular setting. So what do I mean about that? That attribute is manipulated by the sync service when you're doing tiering. So let's say I've got a file server it's an old file server and I've got 10 terabytes of data on there. And I have synced that to the cloud and I've enabled tiering. And maybe now I've only got 2 terabytes of files on that file server, and the other 8 terabytes are up with the master copy up in the cloud. And my antivirus comes along to do a schedule scan, and I haven't cared about what antivirus I bought. I was like, yeah, this one's cheap, or this one comes in a lovely yellow box that we've always bought. And it does a schedule scan on my file server and scans every file. And to do that scan, it's just downloaded everything from the cloud and led to capacity issues on the file server. If your antivirus is using the file attribute recall and data access attribute, it will not download those files that aren't supposed to be there in the first place. So make sure that the antivirus you're buying does support that. Microsoft's antivirus does actually support that setting, and I know that a number of others do as well. So do watch out for that. If you're encrypting your content on your file server, basically watch out for any encryption that happens at the file system level. At the disk system level, that's fine. At the file level, that's fine. But if it's in the file system, like NTFS, then there's a problem. So BitLocker and other similar disk level encryption solutions, they're all perfectly fine. Azure Information Protection, which happens at the file level, that's perfectly fine too. File level encryption, that's perfectly fine. But what's incompatible is stuff like EFS. So the sync service needs to be able to understand the file system and interact with the file system. It doesn't care what's going on underneath at the disk layer. It doesn't care what's going on at the file layer. It's the file system it actually cares about. So watch out if you are using EFS. Your admin interface, primarily is going to be the Azure portal. You can also use Windows Admin Center, and there is an extension for Azure File Sync there, and you can also use PowerShell as well, but primarily I've typically used Azure portal. So the components, you're going to create a storage sync service in Azure. There is no cost for running that service. You're going to run Azure Files storage account. So I would recommend general purpose v2 at this point because of some of the new security stuff that's just gone generally available. And that storage account is going to be pretty important because your backups are going to be in that storage account. I'll talk a little more about that later, but put a delete lock on that storage account. And I would recommend putting it into a dedicated Azure subscription as well, and limiting the number of people who can have access to that subscription. That'll be important because you don't want people accidentally deleting that storage account. Plus, that storage account is going to have all of your replicas in there. Now, you could deploy multiple storage accounts, multiple storage sync services if you wanted to have different patterns of replication and administrative models. But many organizations are just going to have one storage account, one sync service. So make sure that that environment is governed and secured, and you're limiting who has the potential to be able to accidentally delete that storage account or maliciously delete that storage account as well. And make sure you also, I don't have it in the slides, but make sure you have your auditing enabled and you're storing that auditing somewhere safe. The shares themselves, so your shares can be up to 100 tebibytes per share. That by default is actually 5 tebibytes, but you can explicitly ask for 100 tebibytes. Now, if you're curious about what Aidan's talking about when he says tebibytes, I talk like we normally talk about terabytes and gigabytes. Terabytes and gigabytes and megabytes are now for the Apple fans. If you did computer science more than 10 years ago, you would have learned that a megabyte was 1024 kilobytes and a gigabyte was 1024 megabytes. That's no longer the case. Now it's multiples of 1,000. However, to be correct with the billing and scientifically correct, Microsoft use the phrase tebibytes and mebibytes. A tebibyte is 1024 megabytes, whereas a terabyte is 1000 megabytes. So it's just to be precise. So you will see me and hear me use the phrase tebibytes and megabytes in the Azure storage context. So up to 100 tebibytes per share. If if you have more than 100 tebibytes to synchronize, well, you deploy more than one share. And you do your synchronization at a lower level. But 100 tebibytes per share is going to be more than enough for most organizations. Your standard share supports up to 10,000 IOPS. A premium share supports up to 100,000 IOPS. Realistically, I don't think you're going to need premium shares for Azure File Sync. Individual file can be a max of 4 tebibytes. You can have 100 million items per share, 5 million items per directory. So that's pretty scalable. It'd be very rare that anyone will exceed any of those requirements. The storage sync service is really easy to deploy onto a file server. The hardest bit of it is making sure that you have the latest version of the PowerShell modules for Azure. So it'll support Azure RM or AS. And make sure you have the latest one and then reboot the file server. So the hardest part of that is actually just downloading and installing that, getting that maintenance window to reboot the file server in the first place. Then from that storage sync service, there's a link to download the file sync agent. You install that onto the file server and you register it. So it's going to ask for your Azure credentials. And tip there is make sure that when you go into Server Manager, enhanced configuration is turned off for Internet Explorer, because realistically you're going to be using Internet Explorer under the covers to actually do this. If you're using CSP, there is a toggle there that needs to be set in the registration process. It's just a simple on-off button. And then almost immediately your file server will appear as a registered server in the storage sync service. So when you do that sign in on the registration, it'll ask you to select the subscription, the resource group, and the storage sync service that you want to associate the agent with, and that's it. Now the file server is managed by the storage sync service in the cloud and will allow you to configure replication and tiering from the Azure portal. And then you get to the point where you're going to want to start synchronizing folders. So now, a reminder, a server endpoint is the individual folder that you want to synchronize to Azure. So it's that folder on your on-prem file server. You have your storage account that you're going to synchronize into. You have a cloud endpoint, which is the Azure files share in that storage account. And then you're going to associate the server endpoint with the cloud endpoint in the storage account using a sync group. And that's going to have all your configuration for your replication into that storage account and to other file servers as well, if you happen to want to replicate to multiple file servers. Everything in that endpoint, that server endpoint, is going to be replicated to Azure. It'll happen straight away. It will not eat up your bandwidth. It's a very clever system. It's very lightweight. It's not noticeable at all unless you have really, really bad bandwidth. You dial up scenarios. And once that replication has completed, your file server is effectively just a local hot cache. I really want to get that concept across. That file server is now a replaceable appliance. That's the way to think of it. Because your master copy, as I have said multiple times, is in the cloud. You can browse your file shares if you want in the storage account. You can connect to the S3 shares. That will require authentication. I'm going to talk a little bit more about that later on. But you can't just connect to a share from the internet. you have to be authenticated to connect to that share in the first place. You can go into the Azure portal and verify that your files are there. You can use Azure Storage Explorer, which is a free tool from Microsoft as well, to verify that all your files are there. Any modifications on the file server are replicated immediately to Azure, and then replicated out to the rest of the environment, because Azure will know at that point that a change has happened, and it will trigger a replication to the other file servers that may be in that same sync group. However, if you were to make modifications to your files in the cloud, that can take time to appear on-prem. This is a low priority task, and Azure is not constantly looking for changes that are initiated in the cloud replica. In fact, it only looks for them once every 24 hours. So in theory, it could take up to 24 hours for a file edit that happens in the cloud replica to appear on-prem. The idea here is you continually use the file server to interact and work with your files. You don't work with them directly in the cloud, and you always interact with them through the file server. The sync group, it's easy enough. You create a share in Azure Files, then you go to your storage sync service, create a sync group there, associate it by creating a cloud endpoint with the share in Azure Files, and add your server endpoint. So you select the register file server from a drop-down box, you enter in the path of the folder that you want to synchronize in, and you optionally add enable cloud tiering. Now that's something you can do straight away. It's something you can do later on. Something you can modify later on as well if you wish. You don't have to do the cloud tiering straight away. If you want to add a new file server, so let's say you're setting up a new branch office and you want to drop a file server in there and start populating content on it, download that file sync agent again from the storage sync service, create a new server endpoint in the sync group, and put in a folder name and path. It doesn't have to be the same folder name and path as the original server in the headquarter site. It can be completely different. And within minutes, all the reparse points for all the synchronized files will appear on that new file server, and it'll be usable in minutes. So users will start browsing the file share and opening files, and they'll be downloaded on demand from the cloud. At that point, you can consider using cloud tiering. So this is implemented by the storage sync filter driver that I mentioned earlier on. That's the thing that expects to see 2 gigs of RAM when the server boots up. And this will track the temperature of your files. So it knows when files are being used, when they're last used, how frequently they're being used as well. And the frequently being used bit is used to monitor the temperature of your servers, which is a relative thing. There is no fixed definition of what's hot and what's cold. It's all relative depending on that individual file server. When it is enabled, it will move your cold files to the cloud. Well, it doesn't actually move them, they're already there. What it does is it replaces the cold files on the file server with reparse points, which is just an index entry. That's all it is. So instead of pointing to the file on the file system, it points to the file in the cloud. When a file is replaced with a reparse point, you're going to see some attributes on there. So you'll see things like APLO. So A means it's archives synchronized. P means it's sparse. L means reparse point. O means offline. It's up in the cloud. Offline means online in this scenario. The icon of the file will go gray, and your permissions, your name, your file name, your file path do not change. This is the important thing. From the user's point of view, nothing really changes here. The file is still where it always was. The permissions are still the way they always were. It's just now when I go to open that file that's got a slightly grayed icon, it just takes a few seconds longer for it to open. When I do open it, the file system, the way it works is basically the file system goes, right, I need that file, it goes looking for it, goes looking in the index table, it goes, reparse point. I actually need to suck that down from the cloud. It pulls it down. The file is now part of the file system and is then presented to the user through the share. From the end user's point of view, that's all just sausage making that happens in the background. and they don't need to know about it. So it's kind of cool. This slide just talks about how we can have different permission or different file paths and locations and names for the different folders. We can have tiering policy, which can be enabled or disabled. We have a couple of different ways of manipulating the tiering policy. So we can specify that a certain percentage of the volume on my file server, my data volume, should be free. Or I can specify that when files reach a certain age, they should be tiered. So I have that flexibility of dealing with that. It used to be that we could only set a percentage of the data volume should be free, but I had a lot of people asking me about, Microsoft are hearing a lot of people saying, actually, we would like to set some sort of age threshold to say, right, if something is more than 3 months old, just automatically tier it, and we don't need to keep it on the file server at that point. So you have that opportunity there. What happens though, if I have multiple sync groups on my data drive, let's say I have my D drive on my file server, and I have multiple sync groups all there, and they've all got different policies set up. So they've all got policies saying that are percentage based, and I've got accounting that's set up to say, well, there should be 10% free on the data drive. Management is set up to say 20% free on the data drive, and some other folder is set to say, well, there should be 30% free on the data drive. Well, the storage sync service, the filter driver, it sees these as a single unit, basically, and it will apply the strictest one, which is 30%. So it will equally apply tiering across all of it. As far as it's concerned, there isn't 3 folders here. They're basically one unit that are, or one logical unit that need to be manipulated. So the coldest files from those 3 folders will be tiered, and the hottest files will be retained. And not on a per folder basis or anything like that, just as a whole. They're treated as a whole. With different policy types, and there's a clash, so we're looking to have 30% free space on the data drive, and we're also implementing a local retention of 30 days. The free space one will always win, no matter what. So tiering will always try to do its best to make sure that 30% of the data drive is free. So that may mean that there are files that are not yet 30 days old that will be tiered to the cloud. If you need to keep files for 30 days on the file server, then you may need to relax the free space setting or not even use that at all. So some requirements for tiering. It must be implemented on a data drive, not on the OS drive. So it's always been good practice with any sort of server with data to put the data, no matter what that data is, whether databases, file shares, always put that onto a data drive. Files need to be at least 64 kilobytes to be eligible for cloud tiering. If they're smaller than that, Azure File Sync is not actually going to cloud tier them at all. It will just ignore them and leave them on-prem. It's just not efficient enough to deal with files that small for tiering. There are issues with Windows Server duplication. Actually, that one may have changed since I wrote that slide. So I would say if you are using Windows Server deduplication, check that on docs.microsoft.com for the latest policy on that. Cloud tier files will not be indexed by Windows Search. Because the files are no longer on the data drive, Windows Search can't tier or can't index those. So if you are depending on Windows Search for particular folders, you may need to exclude those folders from synchronization. Do make sure that the file server is starting up with at least 2 gigabytes of RAM. Not that it can have 2 gigabytes of RAM, that it can see and use 2 gigabytes of RAM. If your data volume is full, cloud tiering will not work. It needs some free space, some scratch space to work with to be able to do a safe and dependable replication. So you will need to free up some space. So the advice I've given to some people in the past is, okay, your D drive on your file server is full. add some extra capacity, whether it's USB drive, extra virtual hard disk, whatever it is. Temporarily move some of your content, your old content, from the data drive onto that new capacity. Now introduce cloud tiering, and as cloud tiering frees up space on your data drive, move that content from that extra drive back into the original data drive, and it will get tiered eventually as well. And that's how you can start introducing tiering for that for full volume. At that point, if your cloud tiering is set up correctly, you should never have a full drive again. Your backups should be, well, if you are doing backups on-prem, which really shouldn't be at that point, your file system will just be more dependable, more reliable, because you're always supposed to have a certain amount of free capacity on your data drives. So your backup, I just mentioned that a second ago, your backup now stops on-prem. Your backup moves to the cloud. And this is going to be managed by Azure Backup. Azure Backup is actually realistically only an orchestrator. It doesn't store any data in the recovery services vault. That's a big ask from people. A lot of people are asking Azure Backup and Azure File Sync people to support data storage in the recovery services vault. However, the backup solution where Azure Backup is the orchestrator of backups is generally available. And the way it does the backups is you implement the backup schedule in a Azure Backup Recovery Services Vault, and that orchestrates creating snapshots in the storage account, which are stored in the storage account. And you have maximum 200 snapshots per share. So if you're doing daily backups, that will be 200 daily backups. Excuse me. It does not consume from the 5 terabytes or 100 terabyte limits of the file share. It's actually different capacity. There is a storage charge to maintaining those snapshots as well. However, that means the backups are in the same place as the data. So if your master copy is in the storage account and your snapshots are in the storage account, there's a risk that someone deletes the storage account. So as I said earlier, put a delete lock in the storage account. Limit who has access to that storage account. So I would consider putting that storage account into a dedicated subscription, maybe using things like privileged identity management, and also make sure that you're recording the auditing, the activity log data. So don't just trust the 90 days activity log data. I'd also take that activity log data through subscription diagnostic settings and dump that out into a storage account or even into blob storage with immutability turned on that blob storage to make it a read-only audit trail. That way, really only responsible people will have access to the storage account. They can't accidentally delete it because the delete lock is there. It's a deliberate thing you'd have to do. Plus, if you're limiting who can do that, then the number of people who could maliciously damage the storage account is reduced. And if you have the auditing there, well, make it clear that, you know, if you want to maliciously delete that storage account, we'll know you've done it. It will be recorded and you'll be spending some nice, pleasant time in a local prison. Backups, they are only scheduled by the Recovery Services Vault, so it doesn't store data in there. You can also do them manually. And to manage those backups, you can go to the backup settings through the Recovery Services Vault, but you can also go to the backup settings through the Azure File Share as well. And that's one of the cool things that Azure Backup have done is they've given you multiple ways to get at the backup configuration and restore functionality as well. So no matter where you are, you can get to the backup or recovery features of that particular service or resource. I really love how the restore process in this works. It's really sweet. It's all done in the cloud. So it's cloud speed, disk to disk recovery. It's not even across the network, which is kind of cool. So one of the positives of using snapshots for the backups means that the restore is a complete disk-to-disk copy. So whether you're recovering one file or an entire share, the process will complete within a few minutes. And then synchronize back to the on-prem file servers within a few minutes by using reparse points. So let's say you had someone maliciously delete all the files from a file share, or you had malware come in and encrypt everything and send you a nice little email asking for some Bitcoin or whatever it is. With this in place, your backups are completely isolated from the network. There is no SMB connectivity from the network to the storage account up in the cloud. So the malware can't reach your backups. The restore is done completely in the cloud. So it's a disk-to-disk copy from the snapshot back to the file share. So let's say I'm restoring 100 terabytes of data. I restore that, and it's how fast can 100 terabytes copy from one disk to the disk right beside it. That's the way to think about it, even though storage clusters in Azure are way more complicated than that. But it's a disk-to-disk restore. It's not a network restore. It's once that's completed inside of that Azure storage account, the reparse points are sent out to all your on-prem servers. So there's no restore of the 100 terabytes across the internet. It's just the reparse points are sent out. It's metadata. And at that point, users can start using the files again. So the whole process will be completed within minutes of that disk-to-disk recovery inside that storage account. It's really, really sweet to see it in action. I really do recommend, if you have the opportunity, set this up if you want to evaluate it and try it out. Delete everything, do the restore, and watch how quickly everything comes back online in that file server. I really do mean it. It is a thing of beauty to see. You don't have to go out and buy some crazy expensive, backup solutions or on-prem sync appliances that I see at conferences and stuff. This stuff is just sweet, and it's a micro cost to make it operate as well. Enabling the backup is easy enough. Create a recovery services vault. Go to add a backup item, select Azure Files as the option, select your storage account that you're synchronizing to, and then select the individual shares that you want to backup. And create a backup policy, which is basically how many days you want to keep snapshots for. And that's it. Simple as that. And then start monitoring your backups, of course. We also have self-service restore. So this was added in version 9 of the AFS agent last year. So this one actually surprised me how many people have not known this feature is here in Windows. It's been in the Windows client since Windows XP and Windows Server 2003, I think. So basically, we can enable self-service restore on the individual synchronized shares. That basically means that if a user accidentally deletes a file, they don't need to contact IT to restore the file. They can actually just open up the file share, right-click on the blank space in File Explorer and go to previous versions. Or they can go to the individual file and go to previous versions. And select a snapshot of the file and drag and drop. So the restore process is now a file copy. It may not be something that every individual user does. I know when I introduced this back in the days of Windows XP, I think it was late 2003, early 2004, I introduced this to the users. And we basically told a few power users around the organization how to do this. So if they knew somebody needed to recover a file, they would just open up previous versions in File Explorer, drag and drop the old version of the file they needed, and they didn't have to contact IT, and they felt empowered. The division or the group or the team felt empowered that they were able to handle that stuff without having to deal with IT. And this is all manipulated and done through the snapshots that are kept in Azure File Sync as well. So it's all really cool stuff. So talked about that. Disaster recovery, I've talked about this as well. So it's basically the same as the restore process, or the ability to add in a new server. So if I lose an office, I can get myself a new temporary location, set up a new file server, install a file sync agent, register it with the storage sync service in the cloud, and associate the sync groups with that file server. And within minutes, my reparse points appear on the file server. You're hearing me repeat the same thing over and over again because this service is so simple and it does many things using these same few features, which are built on that synchronization engine from SQL Server. So it's really, really dependable and reliable. And we can basically restore that file server to that branch office or whatever it is in minutes once we have a Windows Server machine up and running. And that's going to be the time-consuming bit. That may be you even just set up a machine in the cloud and set up a site-to-site VPN connection or an Azure WAN connection or whatever it is, and or even point to site, and people can access that file server in the cloud. Troubleshooting wise, there are a bunch of logs and tools we have with this. So you've got your installation upgrade logs stored in the C drive in those folders, AFS agent setup and AFS installer upgrade. There is a whole bunch of information in the storage sync service in the Azure portal. So it'll tell you about communications issues, agent versions. So keep an eye out for agent versions that have fallen behind. So if there's any machine that's not upgrading its agent version, you want to do that manually. The sync groups, you'll see the health of file synchronization there in the Azure portal as well. On the individual file server, you can go into Event Viewer and see what's going on too. And on the file server itself, we have two tools. We have a PowerShell script, which will spit out a whole bunch of troubleshooting information called File Sync Errors Report. And then we've got a command called debug AFS, which requires you to import a module, a custom module called AFS.ps1. What I have found, and I've mentioned this over and over, is the storage sync filter driver can sometimes be the cause of the issue. So a couple of things to watch out for, and I mentioned it a few times because it hit me bad when it did hit me. Make sure that file server has at least 2 gigs of RAM when it starts up, and that those 2 gigs of RAM are visible, not possibly available, but are visible. Is the data volume full? So watch out for those errors. Are you running on-prem backup? You shouldn't be anymore if you're doing cloud tiering. Your on-prem backup should stop with that file server. Also make sure your antivirus is respecting that O attribute, the offline attribute, using that setting I talked about earlier. Because your backup could be pulling down files, your antivirus could be pulling down files or doing weird things as well. A bunch of questions I normally get asked at a conference. So is there file lock sync? So DFS replication never had file lock sync. Before it, FRS never had file lock sync. It's a really hard thing to do, implement reliably. And at this time, Azure File Sync does not have file lock sync. So that basically means if a person opens a file in a file server in Dublin and a person opens a file in a file server in Copenhagen, and it's the same file, the last writer wins. So that's not ideal. There are third-party companies that deal with that sort of thing. So I'd say have a look at those. Is there support for that relatively new feature where Azure AD or Azure File Shares can use Azure AD for ORBAC on the individual files? Yes, absolutely. As I said earlier, the permissions are actually replicated with the files. So the permissions are stored with the files, and if you enable the Azure AD ORBAC feature for storage Azure files in a storage account, that will be implemented for you. However, as I said earlier, it's really not recommended that you access the shares directly in the cloud. You should always access them through a file server, because if I make a change to a file in the cloud replica, it can take up to 24 hours for that to be replicated out to the file servers. So do keep that in mind. For me, those file shares should be back-end storage. Everything should be through that hot cache of a file server. Can we use private link? Maybe you're not happy about replicating using SSL encryption over the internet to Azure Storage. Maybe you want to replicate over VPN connection or ExpressRoute connection, so it's a private network that you own, to a storage account that has a private IP address. And yes, you can use private link to do that. It will require 2 private endpoints, one for the storage account and one, so the Azure Files API on the storage account, or the Azure Files service on the storage account, and a private endpoint for Azure File Sync as well. Is there an antivirus solution for Azure Files? The answer to that is no, there is not. However, you will continue to use antivirus on your file server, ideally respecting that attribute I talked about earlier. And you can, as of this week, this is now generally available, you can enable advanced threat protection for Azure Files, or storage accounts to be precise, through Security Center. So again, this is another reason to put your storage account into dedicated subscription. You can then enable Security Center on there, and you don't have to pay for, other virtual machines or databases or whatever that you're not necessarily worried about having a standard tier of Security Center for. So it'll limit the cost expenditure of Security Center. It'll basically just be a single node, which is the storage account. So the file server, it lives. It can continue. It can be cloud integrated. It can be part of your hybrid cloud implementation. For me, it's kind of like the next big hybrid thing for Microsoft. Azure Backup for me, when I started working with Azure lots of years ago, I think 6-7 years ago, Azure Backup was like a big thing because it just gave people this really cheap online backup solution. It was non-disruptive. It didn't break things to use it. And Azure File Sync is the same way. You can literally just drop this agent onto your file servers and radically change your experience with file servers without changing the experience for the business. It's more the administrative side of things, the cost side of things, the ability to recover from disasters or backup issues or malware issues. It's totally awesome. And if you are running branch offices, this thing can really save you a lot of pain. So I can see we're at the top of the hour, and timing worked out pretty decently. I'd like to thank folks from ESPC for inviting me to talk to you again. You can learn more about me on aidanfinn.com, my employers on innofactor.com. I'm on Twitter at Joe_Elway. And if you're interested in doing some Azure Network Security training, I'm running an online class on July 30th, and you can learn more about that on cloudmechanics.com. Shane?
Thanks for a great presentation, Aidan. Yeah, we will quickly do a Q&A part. As you said, we're pretty much out of time. So I just have one question here for you, Aidan, that hopefully you can answer, and we'll wrap it up then. The question is there a way to use a cloud-hosted file server for remote users for them to access the content without VPN using AAD identity for auth?
Using Azure AD identity to access the, no. If you're running Azure AD Connect, then the answer is yes, because you would need a domain controller realistically to be available on the network somewhere. If you need it to be integrated with the rest of the network. You can't just integrate Azure AD into the RBAC on a file server. So you would need to have a domain controller somewhere, and then that could have Azure AD Connect, which would synchronize with your Azure AD. If you don't want to run the VMs for 1 or 2 domain controllers, and you're not worried about single region reliance, then you could also, or alternatively, run Azure AD Domain Services. That actually runs 2 domain controllers under the covers, but presents it as a platform service. And though I would normally prefer to actually just run, a B series virtual machine as my domain controller, and have a site-to-site VPN or ExpressRoute or whatever to synchronize that with my on-prem, and then the Azure network would actually be a new Azure AD site.
Right.
Yeah, that would be how I deal with it.
Super. Well, on behalf of the ESPC community, thank you, Aidan, for taking the time today to complete this webinar. We really appreciate it.
No worries, glad to be here.
Brilliant. Okay, everybody, that is pretty much it for today's webinar. Again, a big thank you to Aidan Finn for his input today. Please see SharePointEurope.com for further details of all upcoming webinars, or visit our resource center for further episodes. Thank you all for joining us today. Take care and goodbye.